Hello everyone. Today we are going to look into LeetCode problem subarray sum equals to k. So this one we are given an array and we need to find what is the possibilities, like what is the distinct possibilities, or we need to find possibilities of subarrays in which the sum of the subarray is equals to k. So let's say for this one, for this one, sorry. For this one, the first possibility is 1 comma 1 and the another possibility is also 1 comma 1. So these two can form one subarray and these two can form one subarray which is equals to sum is equals to k. For this one also. For this one, what we can say is one subarray is 1 comma 2 and another subarray is only 3 itself. So singularity is also considered as a subarray only. That's it. So what is the possibilities here? Also we have two possibilities. So we need to find not the subarrays but how many possibilities we can have. So that is a problem statement, and the main the easiest, not easiest way. So one way that we can solve this issue is by using brute force, but we need to find all the possibilities from this particular subarray. So let's say when considering this one, we need to find all the possibilities. So it is going to take some long time. For this small array itself, we can say this one is a subarray, and this one is also subarray, and this one, and array itself is a subarray. And not only that, so we are just considering this as the first index, 0th index. So let's say I'm having one subarray for second index, first index, and second index, and so on. It is not a very good idea. So then how can we solve it? We need to solve it by using prefix sum. So what I'm going to do is I'm going to use prefix sum along with by using some dictionary to store my values, and I will try to find. So what is my approach to solve this one? So let's take a different example. Okay, okay, we have this particular array, and what I need to find is I need to find the sum is equals to let's take the existing one only. So the sum is equals to 3. So what I'm going to do is first I'm going to start from the array array 0th index, and I will keep on adding these values. So let's say I'm adding 1 and I'm adding 2 and I'm adding 3. So each time I'm finding the sum of the particular array, I'm going to store that value. Let's say for this one, I'm going to store that value in a dictionary. For 1, it is occurred one time. For 2, when we reach to this particular index, our sum is 3, and it is also occurred for one time only. So this is okay, technically, let's make a difference. So this one is a dictionary, and when coming to the third one, the sum is the sum is 6, and it is also occurred one time only. So what is the use of finding this dictionary? So what I am going to do is if sum is equals to this particular k, that means we have one possibility, one subarray in which the sum is equals to this one. And one more condition is, let's say I got this value 6. So I got sum is equals to 6, and what I'm going to do from here is I'm going to find sum minus k, that is 6 minus 3, which is equals to 3. So I'm going to check in my dictionary. I didn't add it yet, so let's consider I didn't add it yet. And what I'm going to do is, after finding out this sum, I'm going to calculate sum minus k, and I will just find if this value is already present. Yes, it is already present. That means I will return whatever the value we are having it here. That means 1. So that means 3 already occurred before this value. Before this value, 3 already occurred one time. That means we have a array with sum of 3 is already occurred before this string, before this array, and that the occurrence is 1. So let's say I'm having one more array. So I'm having this kind of array. So at this time, what I'm going to have? So I'm going to have 4 comma 1, and again, what is going to happen? So it is going to calculate 6 comma 1, and by reaching this point, what we are going to find, we are going to find that sum minus k3 already existed before. So I'm going to increment it, and when I reach this point, I can say that before this particular index we have already two occurrence of 3. 3 means 3 is nothing but the k given value. So what I can say is, by following this way, what we are going to do is, we are going to just just play, like we are going to place our possibilities, what is the sum, and how many times it is occurred, and then we are just going to store it here, and we are going to access the particular dictionary to get the results. So it is simply uh, memorization. So let's try to understand it in a better way from solution. So as I told you before, I'm going to use a dictionary. It's a little bit confusing, but still we can get more understanding while writing the code. So what I'm going to do is, I'm just going to calculate my sum, and another one is count. Count means the subarrays count. Count is 0. So as I told before, I'm going to run through this whole array, and I'm going to run through this loop, and we just going to calculate the sum. Along with that, so once we find the sum, what we will do is, we will check the dictionary. If dictionary contains key of summary, that means if it is already present, then what I'm going to do is, I'm going to increase the value of the summary. If dictionary doesn't contain the sum, then I'm going to add the value. Just I'm going to add a new value, sum with 1. That is, it is existed one time. That's it. And one more thing is, if sum is equals to k, then not written, sorry. So I'm going to increase the count value. And if dictionary contains key sum minus k, okay, this is the condition. If dictionary contains sum minus k, then count is equals to dictionary of sum minus k. So I just explained it in our previous just 1 minute before we explained it. So that's it. So after completing the loop, completing the for loop, we just need to return a count. That's it. Let's give it a try. Let's try to submit it. Oh, what is the problem here? Yes, we can't add sums here. Yes, that's it. It's working fine for the initial condition. Yes, that's it. It's a best solution. So this is my approach to solve the problem. uh, that's it for today. Thanks.